philosopher once said, "It is stern work to thrust your hand into the sun and pull out a spark of immortal flame to warm the hearts of men." Yet in this modern age, men have at last harnessed the sun with the Bell solar battery. Here is one mounted in a protective case of clear plastic. Each of the dark discs is a cell. The cells consist largely of highly purified silicon, a common substance found in sand. Here in the Bell Telephone Laboratories, we can see a finished cell being tested. Just let the sun shine upon it, and you get an electric current, a measurable, usable current, enough to make a telephone work. The sun from which the solar battery takes its power is really the original battery of our universe. From it comes almost all the physical energy on Earth. Sun power stirs the instinct of the seed. The sun's rays drive the process of life itself and feeds all plant growth. The flowers and grasses, the trees, and these in turn support the more complex forms of life, including you and me. The wind, too, is a product of the sun. For ages, man has harnessed it for his labor. The sun's rays have lifted the waters of the sea into the heavens, and in due course, the rain has fallen on the highlands. Trapped on their journey back to the sea, the waters have done man's work for centuries. Now they spin the giant turbines that generate electric power. The ferns and grasses that grew 1 million years ago have become our coal, gas, and oil. And so these fuels which supply the power for all our transportation are also a gift from our ancient solar battery, the sun. But scientists and engineers have never been satisfied with these power conversions. For 1,000 years, they have worked to convert the sun's rays directly into useful power. This old print of 1862 shows an early experimental model of a solar machine, a primitive attempt to focus the sun's rays through a large mirror. Scientists at the Bell Telephone Laboratories have also been trying to harness the sun's energy to find a low-cost source of power to carry your voice. The search became more urgent after their invention of the transistor, for here was a device that needed very little power. Transistors are used much like vacuum tubes, which amplify your voice in radios, telephones, hearing aids, and other equipment. Well, now, even if only a small amount of power could be obtained, it would be enough to make this sensitive transistor work. To find such a low-cost source of power, telephone scientists investigated most of nature's forces. They measured the wind and tested their theories in the field with wind generators of radical design. Would a heat machine do the job? Two unlike metals would produce an electric current when heated. Such machines are called thermocouples. They showed promise too. But man's oldest dream, direct conversion of the sun's energy, proved most successful and practical. Here are the inventors of the Bell solar battery. Gerald Pearson, a research physicist, whose research showed that silicon was particularly suited for converting sunlight into electricity. Calvin Fuller, a research chemist, who developed the chemical process used in the construction of the battery. Darrell Chapin, research physicist, who solved many of the practical problems concerned with developing the battery. Now let's see how the Bell solar battery is made. You start with silicon, endlessly available in the sands that flank the oceans, lakes, and rivers of the world. This is what it looks like after it has been purified. It must be purer than anything you can imagine. In 10 million parts of silicon, only 1 part impurity. And then you add a touch of arsenic to establish the proper electrical conductivity. The mixture is melted in an electric furnace. On the rod above the molten silicon, you have attached a seed crystal of pure silicon, which is lowered into the mixture. Now the silicon attaches itself to the seed, and guided by its structure, the finished crystal slowly grows. This is only the beginning, for now the crystal must be cut. Only a thin wafer is needed for each cell of the battery. Cooled and lubricated by the constant spray of water, this diamond saw shears through the crystal with amazing precision. The rough wafer is carefully polished to restore the atomic structure of the surfaces altered by the stresses of cutting. It is measured for the proper thickness. The polished wafers are sealed in a quartz tube filled with boron gas and baked in a furnace. To see what happens to the wafer while it is being baked, let's look at a cross-section of the wafer as it might appear in the furnace. The high temperature causes the boron gas to penetrate the surface. A closer look shows that the boron gas releases positive charges. The arsenic releases negative charges. But these charges do not mix because in nature's wonderful plan, the boron and arsenic have created an electrical fence. Now the quartz tube containing the silicon wafers is taken out of the furnace. And after removing them from the tube, you go about the delicate job of attaching wires to the positive and negative sections of the cell. Now it is ready to go to work. How does it work? Well, let's go back to the enlarged cross-section of the wafer. Particles of energy from the sun penetrate the surface and crash against the silicon atoms near the electrical fence. At each crash, the charges build up and an electrical current begins to flow. The battery has indeed converted light to electricity. And here are the inventors making a test of their newly harnessed power to operate a small radio transmitter.
This is a demonstration of the Bell Solar Battery in practical application. Do you hear me? Do you hear me?
Here are some of the many models that Bell telephone scientists have developed in their efforts to improve the battery. Today, they're almost twice as efficient as the original one. Their efficiency is now comparable to that of the best gasoline engine. They have no moving parts or corrosive chemicals and therefore should never wear out. The solar battery also works on cloudy days. It can charge a storage battery during the day, thus making power available day and night. Here the Bell Solar Battery is mounted on top of a pole. It charges a storage battery in the small white box, which furnishes the power to operate the telephone equipment in the large box. This special equipment, which uses transistors to save space and power, makes it possible for several people to talk at the same time over one telephone line. George Matthews was the first telephone customer to make a sun-powered call. In addition to the part it may play in telephone service, the battery holds great promise for the future in other fields as well. It is possible that someday children may soon have toys powered by the light in the room. Portable radios powered by sunlight have already been made as laboratory models. Their solar batteries will work as well by artificial light. On a more serious side, you may have seen articles forecasting the use of the Bell Solar Battery in Earth satellites. At the American Museum's Hayden Planetarium in New York, you can see this plastic-shelled model of such a satellite. When it becomes possible to establish permanent satellites, their radio transmitters, which will send important data back to Earth, could be operated indefinitely by Bell Solar batteries. Who can say what part the Bell Solar Battery will play in the future? Indeed, man has at last dipped his hand into the sun and drawn down a spark to warm the hearts of men.